This video is on atom, gram, volume, and mole conversions. You can be using the roadmap, and I also have it up here. Okay, so these problems are quite frequent in chem. And this first one we're going to do is the gram to mole conversion. You're going to see a lot of this, and you're going to use it quite often, so it's very important that we know how to do it. If you look at your roadmap, in traveling from grams to moles, okay, no matter which direction you're going to be using the molar mass, which is defined as the mass of 1 mole of an element or a compound. And you get that number from the periodic table. So if it's just an element, its mass is just its atomic weight. So for example, lithium, who has an atomic weight of 7, lithium's molar mass is 7 grams per mole, meaning 1 mole of lithium weighs 7 grams. If you have a compound, then you have to add up their molar masses to get the mass of 1 compound. And we'll see that in my example. Okay, so let's say this is my problem. 64.2 grams of CO2 is equal to how many moles? So we solve this with dimensional analysis. And the discussion, of course, here is I'm trying to get rid of grams, so grams go on the bottom, and I'm trying to solve for moles. Knowing that I can travel between grams and moles shows me that this is a one-step problem. So I have this set up. I'm ready to go. 1 always goes with mole. And then the issue here is, what's my molar mass of CO2? So to find molar mass of CO2, I just add them up. 1 carbon, carbon's molar mass is 12. And I have 2 oxygens, so that's 2, 16, so that's 32 and 12, which is a molar mass of 44 grams per mole. And so I just bring my 44 down into here, 44 grams per 1 mole. I do my math, which of course in this case is division. And if we're going to talk sig figs, which I guess we should, this number here is always going to tell me my sig figs. So I should have 3. And so I'll round my answer off to 3 sig figs, which would make this 1.46 moles of CO2. And there's my answer. The second problem is very similar. It's actually going the opposite way. We're given moles, so we're starting here and asked to find grams. Go to here. Same idea, using molar mass. So I set up my problem with dimensional analysis. Moles on the bottom because I want to get rid of them. Grams on the top because that's what I'm trying to find. Moles cancel. 1's always with mole. And then I do a molar mass calculation for aluminum oxide, which in this case is 2 aluminums at 27 and 3 oxygens at 16, which is a molar mass of 102 grams per mole. And that 102 goes right here. This time I'm multiplying. And again, a sig fig discussion. This thing is what's going to limit me. I have 3 sig figs. So round my answer off to 3 sig figs, and I get 326 grams as my answer for that one. So that's gram and mole conversions. And I did not bring an eraser, so give me 1 second. Okay. All right, so next let's do, I erased my mole roadmap. Oh well, we'll use the other one. Okay, let's this time do, I don't know, moles and atoms. So let's say we have and all right, so in this first example, I'm given atoms and I'm asked to find moles. So if we look at our roadmap, I'm given atoms, that's over here in Particle City, and I'm asked to find moles. And so this is the road that I'm traveling right here. And if I read my road sign, it says I'm going to use Avogadro's number. So I'll show you how to solve this one. So again, all of these are solved with dimensional analysis, a discussion of what units cancel. Atoms on the bottom, moles on the top. As before, the number that always is with moles is a 1. So 1 mole, and then this is where Avogadro's number comes in. There are 6.022 times 10 to the 23rd atoms in a mole. If you notice your atoms cancel, all you have to do is your math, which in this case is division, and you will round to 2 sig figs this time because of the 6.5, which will give us the number 11 moles. So that's the answer to my first one. And my second one, 3.85 moles of water have how many molecules? So molecule, and my abbreviation is MC. Molecule is a group of atoms stuck together. So H2O is a molecule made of 3 atoms, 2 hydrogen and an oxygen. So if I'm going to solve this one, it's still the same discussion, same way. Set up to get my units to cancel. Moles on the bottom. In this case, molecules on the top. And I have to ask myself, is this in fact a molecule? And if it is, then the answer is that I can do this in one step. And of course, H2O is a molecule. So 1 mole, as always. And in 1 mole, there are 6.022 times 10 to the 23rd molecules of H2O. We would multiply in this case around to 3 sig figs, and my answer is 2.32 times 10 to the 24th molecules of H2O. So that means groups of H2O, so to speak. There's 2.32 times 10 to the 24th groups of H2O. Now here's one that's always a little bit confusing for students. So we'll do that next, and then we'll incorporate a volume calculation into this as well. All right, so let me come up with one real quick. Okay, so this was our question. How many atoms are in 2.6 moles of CO? That's, of course, carbon monoxide. We would start it like before, using our roadmap, 2.6 moles. I'm trying to get rid of moles, so moles on the bottom. And most students are very quick to put atoms on the top right here. However, that is a mistake, and it's misleading because this CO is not an atom. So because it's not an atom, I first have to go to the unit of measure that it is, which in this case is since it's not an atom, it's a molecule. It's a collection of atoms. So I'll go to molecules, and in 1 mole there are, of course, Avogadro's number of molecules. Okay, so my moles cancel. And now I'm left with molecules, so this is where we think about, well, if in every one of these molecules, how many atoms are there? Well, there are 2. There's 1 carbon and 1 oxygen. So that becomes your new conversion factor, that in 1 molecule, there are 2 atoms. And now, my units cancel. I do my math, which in this case is all multiplication. And I round still, of course, to the beginning number of sig figs, so 2, and I get 3.1 times 10 to the 24th total atoms in this case. So that's all carbon and all oxygen. All right, we'll do 2 more. I'll give you one that has volume because we haven't done a volume problem yet, and then one that's another multi-step one. So come up with something real fast here. And okay. All right, so in this first one, we had 150.4 grams of O2. We want to know how many liters that is. So using our flow chart, we're given grams, so we're over here in Grahamville, and we want to find volume in liters, and that's up here. So if you notice, there's no road that connects them directly, so we have to jump down here to moles first, and then up to liter. So this can be a two-step problem, 150.4 grams. So one step at a time, grams first to moles, grams on the bottom, moles on the top, so they cancel. 1 mole, I'm using molar mass, so O2's molar mass is 2 oxygens, 216s, so that's 32. And then you can, of course, stop here and solve this mathematically, but it's so much easier to keep going, so we're just going to keep going. And now we're in moles, and we're trying to change to liters. So moles on the bottom, liters on the top, always a 1 with mole, kind of a nice cheat to remember. And then if you can't remember this conversion, it's on your flow chart, and this is the molar volume conversion that says that 1 mole is equivalent to 22.4 liters. Now I do my math. There's several ways we can do this. We can do 150.4 divided by 32, hit the equals button, and then multiply by 22.4. Or if you're more comfortable, you can do the 150.4 times 22.4 and then divide by the 32. But either way, you're going to get the same answer. And again, rounding to sig figs to match my first answer, which would be 4, I get 105.3 liters. So there's my answer. And this works as long as the question stated that we were at STP, standard temperature and pressure, so I guess I should have stated that. When we get into the gas chapter later, that's going to be a bigger deal. For now, it's not such a huge issue. Okay, my last one, I'm given atoms of Mg and I want to find grams of Mg. So using my roadmap, if you think about where you are, we're in particle city over in atoms, and so if we're looking at this, we're in atoms and we want to get to grams. Notice there's no road, so I first have to go through moles. It's kind of a common theme. We're always going through moles. Okay, so atoms to moles, 1 mole has 6.022 times 10 to the 23rd atoms, or Avogadro's number. And now that we're in moles, we can continue it and do a molar mass calculation for every 1 mole. And this is where I pull it from the table. It's just Mg, so Mg's mass is 24. All my units have canceled except for grams. Again, mathematically, you can solve this problem 2 ways. Multiply these 2 numbers and then divide by this. Or take this, divide it by this, hit equals, and then multiply by 24. Either will give you the same answer. Let's see, I did not do this ahead of time. To 2 sig figs, because of this number here, my answer would be 220. That final 0 is not significant because there is no decimal. So that is a quick review of grams, moles, atoms, and liter calculations.